1.3, average rate of change and relative change. So average rate of change is the application of slope, which we talked about earlier. So let's take a look at our first slide. So we have the definition on top here. If y is a function of t, so y is f of t, so it means the variable y is also represented by the function of t. Then the average rate of change of y is delta y over delta t, meaning the change of y over the change of t. I remember that we talked about this symbol delta. It means the change of y over the change of t. Right. Now we're using t because most of the application that we're looking at is in terms of time, right? So we have f of b over f of a over b minus a, and that is the same thing as y2 minus y1 over t2 minus t1, right? Remember from 1.2, instead of using t, we're using x. Okay, so let's look at a really simple example, example 2. Use figure 1.30. Estimate the average rate of change of the number of farms in the US between 1950 and 1970. Right, so these are the times, which will be our T1 and T2. Right, so let's look at the y value using this graph. So horizontal axis, we have the year, which is our T. So T1 is 1950, which is right here, T1. And then T2 is 1970, which is right here, T2. All right, so let's look at what their y values are for T1 and T2. So for T1, we are about right here. And for T2, we are about right here, right? So actually, by looking at this graph, it's really hard to see the exact y value, right, which is the vertical value. And the y values are, but here the question actually gave us that for y2 this is 2.8, and for y1 this is 5.4. All right, and to find the average rate of change, you just need to calculate the slope of the line that's passing through these 2 points. Right, imagine that there's a straight line passing through these 2 points, and we want to find the slope. Now, keep in mind that this slope does not represent the exact rate of change from here to here. It's the average rate of change, right? So we can get an approximation of how what's the approximation of the rate of change from T1 1950 to T2 1970. Right, so here we go. We have the change of n, which is a change of the number of farms over the change of time. Right, so we have 2.8 minus 5.4 over 1970 minus 1950, which comes out to negative 0.13. And this number is the same as slope, right? So, but in this case, we are looking at the average rate of change, which is determined by, it's the same as the value of the slope. So in this case, we say that it's negative 0.3 million farms per year. So what this is saying is, on average, between the year 1950 to 1970, every year there's going to be a decrease of about 0.13 million farms per year. Okay, so that's what average rate of change means. All right, to visualize the rate of change, we're going to look at the first graph, 1.31 first. So we have a curve, right? A curve right here. And we picked out 2 points, point A and point C. All right. Now, since this graph is a curve, it wouldn't make sense to talk about their slope, right? Because slope only applies to linear functions where you have y equals to mx plus b, right? So a quick review. For a linear function, we have y equals to mx plus b, and that is, a really standard linear equation where m is the slope. But it wouldn't make sense to talk about slope on a curved line, right? Because at every point of the line, it's a little bit different, right? So what we're going to do is we're going to take these 2 points as our test points, and we are going to draw a straight line through it, right? So this little black line, I'm gonna call it y1, right? So let's say y1 is the straight line that's passing through the 2 points, capital A and capital C. Now we get a linear equation, right? So this can be represented as some mx plus b because it's a linear, it's a straight line. It doesn't turn, it doesn't have any jump or cutoff point. So we can represent this line using a linear function or a linear equation. And to find the slope of this line y1, we're going to apply the formula, right? Now, is delta y over delta x, right? Or y2 minus y1 over x2 minus x1. Right, that's the formula for the slope. So what we get from this formula, or m, is the slope of this straight line, which also means the average rate of change from point A to point C of the original graph, right? So when we talk about the slope here, it's referring to the equation y1, right? This linear line. But when we talk about the average rate of change, we are talking about this blue curve right here, right? So this is y, right? So this is the idea of average rate of change. It's represented by the slope of the straight line, okay? So the same value m that we got from the formula here represents two things. First thing is the slope of y1, the straight line, the little thin straight line right here. And that value also represents the rate of change from point A to point C. Now, keep in mind this term average is very important. It's not the exact rate of change. It's just an average and approximation. All right, problem 27. This is an example for production of tobacco in the U.S. And we have two parts. Let's look at these two parts. Part A, what is the average rate of change in tobacco production between 2003 and 2015? And part B, during this 12-year period, are there any one-year interval during which the average rate of change was positive? If so, when? Okay, so go ahead and pause the video, and I want you guys to take a few minutes to try out the two parts of this problem, and we will come back. Once you come back, we will show the answers. All right, so for part A, just go ahead and apply the formula, right? Change in the tobacco production over the change in years, right? So in 2015, we have 711 millions of pounds. And in 2003, there were 803 millions of pounds. So you subtract those over the change in years, which is 2015 minus 2003, and you get something about negative 7.7. So negative 7.7, this value means it's an average decrease of 7.7 million pounds per year in tobacco production. Okay. And let's look at part B. During this 12-year period, are there any one-year intervals in which the average change was positive? All right. So before we move on to finding the answer, we need to understand what this question is asking, right? So any 1-year period, that average rate of change was positive. Now, in order for average rate of change to be positive or slope to be positive, the value, the y value, or in this case, the production has to be increasing, right? So slope positive means increasing, right? So we need to find out in which years we have increasing production of tobacco. All right. So let's see. We look at the production, see if it's increasing. Right, so A03 to A2, that's increasing. That's decreasing. That's increasing. That's increasing. And that's also increasing. Increasing. 823 to 718. No, that's decreasing, decreasing, and then increasing again, decreasing, increasing, and decreasing, right? So we actually have a few of them that have increasing production, right? So let's look at this. First one is 2004, 2006, 2007, 2008, 2009. I guess during those time, a lot of people are smoking. 2012 and 2014, right? So in all of these years, we see increasing production of tobacco compared to the previous year. Now, we are looking at 1 year interval, right? For example, if we are looking at 2 year interval or a 3 year interval, then the answer will be a little different. Okay. All right. And that's it for part B. Concavity. So concavity is the behavior of graphs, right? So you can look at the definition or you can look at the graph, but it's very straightforward. Right? So concave up means you have something like an opening cup, right? A cup opening up, right? If your graph is part of a cup that's opening up, then it's concave up. But if your graph is part of a bowl or a cup that's opening down, then it's concave down, right? So you can see that this line right here, this blue line of concave down, it's the same as this part, right? And this one is the same as that part, right? So that's basically it. And to be uh, an exception would be a line is neither concave up nor concave down, right? If you have, let's say, a line like that, right? You can tell if it's concave up or down, right? Because it doesn't have the little curve like what we have here, the little curve that tells us whether it's concave up or concave down. Okay. So next, let's look at some example. All right. So problem 7, for which part of the consecutive points in figure 1.38 is the function graphed, right? So we have 4 parts. We're looking at increasing, decreasing, concave up, concave down. Okay, so I'm going to just do one segment with you guys, and I want you guys to try the others on your own. So let's take A to B, right? A to B. We're just looking at this segment right here. Okay, so first let's determine whether it's increasing or decreasing. Now remember the idea of increasing and decreasing. If you're traveling to the right and you go up, that's increasing, right? You're moving to the right, right? But if you're moving to the right but you are going down, that means it's decreasing, right? So from A to B, I'm gonna walk from A to B. I have to climb up this hill, right? So that will be increasing. All right, now let's see if this is a concave up or concave down. Right? Now it's probably a little hard to see, but you can see a little turn right here, right? So I'm gonna zoom in on this part of the graph, right? Which gives me something like this. Up and then a little curve like that, right? So this is part of a cup that's opening down, right? It's this part right here, right? So this would be concave down, right? So CC down, right? So CC, that's a short way of writing a concave. So we have concave down and increasing, right? So increasing and concave down, that will be B, right? So from here, A to B, A to B. Okay. Now go ahead and figure out the rest on your own. You have B to C, C to D, and so on. So we have 1, 2, 3, 4, 5, 6, 7, 7 more. All right, go ahead and pause the video and try this on your own. All right, so here we go. B to C, that will be decreasing and concave down. CD will be decreasing, concave up. And DE will be increasing, concave up. EF will be increasing and concave down. FG will be decreasing, concave down. GH, it's a very hard to see, and I don't blame you guys if you don't get this. GH will be decreasing and concave up. HI will be increasing and concave up. Now, feel free to write down on your notes. So if you have any question, feel free to drop by my office hour, and I can show you some other example and help you clarify a few things. All right, so that's it for problem 7. All right, let's look at an application of average rate of change, which is an average velocity. All right, so here we are looking at, we're traveling, right? Let's say going from A to B, we're driving, right? In some amount of time with some distance. Okay. Now, if you're driving, it's almost impossible to maintain your speed, right? For example, let's say you're stationary at point A, you're driving to point B, right? At some point, you have to start pressing on the gas, and then it's increasing speed, and maybe you hold at a certain speed, but as you are approaching point B, you have to step on the brake, right? Yeah, step on the brake, not step on the gas, or you'll go over. Right? So the speed that you're traveling between point A and B is not constant. It's not always the same, right? So it's very, very hard for us to find out exactly what your speed is at this at some given point in time, right? So what we can do is we can find out on average how fast you were traveling from A to B, just an average, right? So here we have a table, right, given you in time in seconds and y in feet, distance traveled, right? So I'm gonna make a note here. This is the distance traveled, right? So we know that to find speed is the change in distance over the change in time, which is on top right here. All right, I'm gonna box this up. Okay. All right. So in order to find that, we just find the difference in distance and divide that by the change in time. All right, so let's look at example 8. Find the average velocity of the grapefruit over the interval t equal to 4 and 6. Explain the sign of your answer. All right, so we are throwing a grapefruit above the ground. Right, so at the moment we start throwing, it's t0. Right, and then the grapefruit is going to go up and then back down to 0, right? And then this is the number of seconds, right? So this actually, we are having a really strong man throwing the grapefruit, right? It took over 6 seconds for it to come back to the ground. All right, so let's see. We want to find the average velocity of the grapefruit over the interval from t equal to 4 to t equal to 6. All right, so imagine that you're throwing some object into the air. Right, it's gonna go up and then reach its highest point and then come back down. Right, so we want to find out from 4 seconds to 6 seconds, which is starting to go down, how fast is the grapefruit coming down to the ground. Right, so let's look at the solution together. So the height at 4 seconds, it's 150. right? And the height of the grapefruit at 6 seconds is 30 feet, right? So you subtract the feet, divide by the difference of seconds, right? So you have 30 minus 50, or right here. This is the solution part, right? Average velocity is the change in distance over the change in time. The change in distance is given by year, right? So at 4, we have 150. At 6 is 30. So we do 30 minus 150 over the change in time, which is 6 minus 4. And that gives us negative 120 over 2, which is negative 60 feet per second, right? So take a moment to think about what this negative means, right? So negative means you're coming down, right? Speed is negative, negative speed. I shouldn't say speed, I should say velocity, right? And if you're going upwards, you get positive velocity, right? So here is a technicality between velocity and speed. When we talk about velocity, we care about the direction of the object is traveling, right? Is it up? Is it down, right? That gives us a different sign in values, right? If it's going up, it's positive. If it's going down, then it's negative. On the other hand, when we talk about speed, speed does not have negative value, right? Doesn't matter which direction you're traveling, right? Think about driving, right? Doesn't matter which direction you're driving. On your dashboard, it shows the speed is always positive, right? You're never going to see negative speed on your car, right? So speed only tells you how fast you are going. It doesn't tell you the direction you're going. It only tells you how fast you're going. Okay? So right here, last part, the negative sign means the height is decreasing and the grapefruit is moving downwards, right? So upward velocity is positive, downward velocity is negative. All right, the second part of 1.3, we're looking at relative change. So before we move on with the definition, I just want to give you a quick example, right? So let's say in the year 2000, right, gas was $1. I know it's not $1, but let's just say it's $1, right? And now let's say in the year 2020, gas is $3, right? So we know that gas is more expensive now, but how much more expensive it is, right? How much? Oops, can't spell. How much more expensive is it? Right now we know, of course, you can subtract it and you get $2, right? It's $2 more expensive, but what is it in terms of percentage, right? That's what we're looking at. Okay, so we know that the difference is $2, right? So $2 increase compared to the original $1, right? So $2 increase compared to the original $1, that gives us a 2, right? If we do 2 divided by 1. So this 2 means it's 200%, right? So from the year 2000 to the year 2020, the gas price increased by 2000%, right? And that is the idea of relative change, right? We are calculating the change comparing with the original price of the gas, right? We're comparing the difference in price of gas among this 20-year period comparing to the original. Right, so this is the formula right here. Relative change is change in P over P0, right? So P0 is the initial value, the initial. So we're always comparing the change with the initial value to get the relative change. And it's often expressed as a percentage. Okay, so let's take a look at this. The number of sales per week of a $75.99 pair of jeans is 25 pairs. The number of weekly sale goes up by 45 pairs when the price is reduced by 30.3%. Find the relative change in weekly sale. Okay, so this is a really interesting type of problem, right? You're selling jeans and then you're having a discount that attracts more people to buy, right? Of course, we are not going to get into the business model or the economic point of view. All we're caring is about um, what's the change of the pair of jeans sold, right? So per week is usually 25 pair. So that's your initial value, right? Which is your P0 or P naught. The number of weekly sale goes up to 45 pairs, right? So initially you have 25 pairs, right? But now at discount, you sold 45 pairs, right? So what's the relative change, right? So let's look at the solution here. The quantity sold goes up from 25 to 45, right? 25, the original initial, goes up to P1, the number of pairs sold during a discount price, which is 45. We have relative change. We take the new value, P1, subtract the initial value, P0, and comparing with the initial, right? So the 45 minus 25 here, that's your P1 minus P0, right? That's the difference, right? Sometimes it's increasing, sometimes it's decreasing, right? But you have to put this two value in this order, right? The final value subtract the initial value and comparing with the initial value. Okay, so we get 20 over 25, which is positive 0.8, positive. And make a note, this is positive, right? It means there's an increase of change, right? And how much more? The number of sales per week grows by 80%, right? 0.8 is equal to 80%, right? Now, suppose if we have a negative right here, right? Let's say if I get, let's say relative change is negative 0.15, right? What does that mean? Right? So negative means instead of selling more pairs, we are selling less pairs of jeans, right? So negative would mean a decreasing in sales, and how how big was the decrease? It's 0.15, which is a 15% decrease. So decrease by 15%, right? So that's what the positive or negative sign means in this case. All right. So a key point to remember is that you are always comparing the difference with the initial value. Okay. All right. So here I want you guys to do a little more work on your own. I want you guys to try this. Find out maybe a piece of electronic, can be your cell phone, can be your laptop, or your iPad, or your tablet, anything you want that you have in your house that is a little old and you want to replace it with something new. Right. I'll show you an example. Right. I have now an iPhone, um I think it's 6S. I forgot exactly what the model is, and I don't know exactly how much is it. I'm just gonna say it's $100. Actually, I'll be very glad if I can get $100 for my iPhone now. All right, so it's worth $100, right? And I want to replace a phone. I want to replace my phone with, I want to say the iPhone 11, whatever model that is, SR or something. I don't know. Right. And I think last time I checked, the most expensive one is $1,399. Okay, so you don't have to do it with your phone. You can do it with some other stuff. So find out what the percent increase of switching to a new phone is. What's the cost, right? So initial value will be my iPhone 6s, which I still like it very much. Don't get me wrong, right? That's my initial value. And the new iPhone that I want, it's the new pricing, which is $1,399, right? So I'm going to perform the relative change formula, right? Which is P1 minus P0 over P0. All right. So the new phone that I want is 1399 minus my iPhone 6s, which is $100, and divide by 100, right? So what do I get? That's 1299 over 100, which is 12.99. I'm just gonna round up and say 13, right? So 13 means I'm going to get an increase of 1,300% if I switch to a new phone. Right now, actually using the 100 is not a good idea because I forgot how much I got it for. But if you can find out how much you got your old phone or TV or tablet, whatever it is for, then you can find the a better approximation of the increase of cost it is. Right. So here's what I want you guys to do. All right. So first, I want you guys to pick an old electronic furniture or appliances, anything you want really, and find out how much you pay for it. Or if you cannot find how much you pay for it, then just find out how much is it worth now. Right? Maybe like $50 or $100 for my iPhone. I forgot. And three, pick a new one and find out its price online, right? Online, you get a lot of places that you can buy electronics, furniture, or appliances. And if you want, you can look for the cheapest one you can, right? Either at on Amazon or Best Buy or any places that is having discount. Um, and four, find out what the relative change is if you decide to get a new one. All right. So I want you guys to post this on the discussion board. It will be available by the time you watch this video. So go ahead and post your result on discussion board. And thank you. That will be all for today. And I'll see you next time.